had two questions this week about optics related to calculations on objects, distance, and how it works with concave mirror. So I have an example for them. And if it happens that as we go along, you have clarification questions or you want me to have more examples for you, put your questions and comments in the comments of that video. So here are the few things we have to keep in mind. If you have a concave mirror and you're looking for calculations, we need some equations. So the equations for the concave mirrors and the convex mirror goes like this as well. So you have 1 over the focal length equals 1 over the distance of the object plus 1 over the distance of the image. Now the other one we have is that the height of the image divided by the height of the object equals another ratio, the negative value of the distance of the image over the distance of the objects. And this actually gives us the magnification of the image compared to the object. Like this. Okay, so let's see if we can figure out the calculations. So first of all, let's look at the word problem I have for us. So here I have a concave mirror that has a focal distance. So the focal point is at 8 centimeters from the mirror. We also have that there's a 5 centimeter object in front of that mirror, and it is at 12 centimeter from the focal point. So here, let's look at the information we have and what we can calculate. So first of all, we have the focal point, which is at 8 centimeters. We also have the distance of the object. We also know that the height of the object is 5 centimeters. And now we're looking for two things: the height of the image and the distance of the image in front of the concave mirror. But what's beautiful with these equations is that each of them have a certain number of variables. So here, if I have 3 variables, if I'm given 2, I can certainly find the third one. If I have the focal point and the distance of the object, I can certainly find the distance of the image. But before we do the calculations, I'm going to do a quick drawing on how this will look on the drawing, and that will give us clues about how our answers should be. So let's see if we can do that together. So first of all, if you have a concave mirror, your drawing would look like this. So here I have my concave mirror. I have the focal point, it is at the front. And I have the center of curvature right in front here, because the focal point is in the middle, is the middle point between the vertex and the center of curvature. We know that the focal point is at 8 centimeters. So that's something we know. If this is at 8 centimeters, that means that the center of curvature is at 16 centimeters. Okay. So we know that much. We also know that we have an object, and the object is at 12 centimeters. So halfway between 8 and 16. Okay, let's put a different color. So it's right there, and we know that the object is 5 centimeters in height. So here, this is the object. That object has a height and also has a distance. So you see how all of these are working out. Now, in order to know where the image is, we're going to need some rays of light, so we can figure out where we can find it. So from previous drawings, we know that if you have a light ray going from parallel to the main axis, it's called the principal axis, there you go, and it goes at one point of your object, it will be reflected going through the focus. Like this. Now what's interesting is that if I go for another ray that goes through the focal point, then it will be reflected parallel to the principal axis. something like this. Okay, so that's good. Another one we can say is that if we have a light ray that goes to the vertex, right here, right there, the angle of incidence equals the angle of reflection. And therefore, we have the third ray. Now, what are we going to do from there? So let's look at the information we have. We have here a point of intersection, which is at the tip of that object, and that object is perpendicular to the principal axis. So what do we do from here? We know that there's another meeting point right there. So that means that if you have an image, the image will also be as a tip right here on the intersection point, the same thing as this one. Now we can figure out some things interesting about this image right now. First of all, it is inverted. So here it is inverted. Inverted. The other one, we know that the height of the object is smaller than the height of the image. So that's something we know. How about the distance? The distance between the mirror to the object is smaller than the distance from the mirror to the image. Is smaller. Very nice. So these are things that we can say even before we do any calculations. So let's see if we can do some calculations right here. So first of all, we're going to take our first equation. Like this. Since I'm looking for the distance of the image, I'm going to have to take this term on the other side. Now we just have to include the data in our formula. Twos. Perfect. Now, what's interesting, we have two fractions. So let's see if we can do the calculations here. When you subtract two fractions, let's see if we can have common denominator. So here we have 24. There we go. So we know that 1 over the distance of the image equals 1 over the distance of, it equals 1 over 24. So we have here the distance of the image. So we can put that in the data we have here. So the distance, 24 centimeters. So that's good. Now what do we need? We need to have the height of the image. Now, if I'm looking for the height of the image right here, that means that I need to isolate this term, this variable. If you divide by the height of the object, you will multiply it on the other side. So I'm going to transfer this equation on that side by doing the transformation. So the height of the image equals negative di over do times the height of the object. So here hi equals negative di, so negative 24 over 12 times the height of the object. And so negative 24 divided by 12 is negative 2. Negative 2 times 5 is negative 10. So here's my information. So here that we have a negative sign. So that means that we have an image that is inverted, which is good. We had inversion right there. Perfect. Let's look at the height now. If you look at the height or the absolute value of the height, we have a height of the image that is 10, that is taller than the object. Here, that works nicely. If you like math, you could say the absolute value of the height of the object is smaller than the absolute value of the height of the image. How about the distance now? We know that the distance of the object is 12 centimeters, and the distance of the image is what? 24, which means it is further than the distance of the object. And on top of that, we know that it is past the center of curvature because the center of curvature is 16 centimeters. So here our drawing gave us a very good clue what the answers would be. So here we were able to find the distance of the image and the height of the image, and being able to also say what kind of information we have. There's something else. The type of image. If I am to take a screen, we could say that this image is a real image. And the reason why it is a real image is that if I have a screen, I could actually project on that screen that image right here. That's the difference between a real object and the other one is a virtual object. A virtual object would be behind the mirror. So if you go into the washroom, for example, and you have a mirror and you look at yourself, you know that you are in front of the mirror and your image will be inside the wall or behind the mirror. And there's no way for you to go behind the mirror to try to put a screen to do a projection. So that's a big difference between a real image and a virtual image. On this, if that brought some questions as we watched the video, please put your questions, your clarification questions in the comments below. I always look at them and see if I can actually bring, first of all, answer your questions. Second, if you're looking for more examples, you tell me and I could do more examples for you if you want to. Just tell me. I'm here to make sure that you succeed. On this, I'm going to put here a link to another video about the optics and how lenses work here and in optics. And I'll see you there.